Welcome to all. Question number 14. Last class, the closing question. After 11 and 12, I first wrote 13. Then I thought it is 14. So change it to 13. No, 14. Again, question. A simply supported beam of span 6 meter is loaded by an uniformly varying load with the intensity of 8 kN per meter at the left end, which linearly increases to 23 kN per meter at the right end. Or they can tell 23 kN per meter at right end linearly reduces to 8 kN per meter. Or they can tell uniformly varying load represented by a trapezium with the intensity of 8 and 23 at left and right end respectively. Okay. Now, along with the 2-point loads of 50 kilonewton and 40 kilonewton at 1.8 from left end, 1.5 from right end. Okay. Write all this one, usual statement. Option 1. First you make it. Option 1, first you write a note here. The note is that trapezium is there. You should write, I am not afraid of trapezium. So, just recollection, if trapezium is there, see, 8 kN per meter, I am not written here, 8 kN per meter, 23 kN per meter. If the load is like this, you know it, centroid will be slightly this side, total load equal to area of the trapezium, sum of the two parallel sides, 8 plus 23, 8 plus 23 divided by 2 into loaded length is 6. This is total load. See, this is the total load, and centroid is from here 8 plus twice of 23 divided by 8 plus 23 into 6 by 3. This side plus twice of that side divided by this side plus that side into distance between the two sides divided by 3. Already explained many times, maybe more than 30 times. Still, see, teacher's instinct, what to do? Okay, start now. Minus VB into 6 plus first point load 50 into 1.8, 40 into from 6 subtract 1.5, 4.5. Now make a note here. Entire trapezium. So you write here full trapezium. This is the resultant load, total load. The total load equal to 8 plus 23 divided by 2 into 6 is the total load into from here to here is 8 plus twice of 23 divided by 8 plus 23 into 6 divided by 3 equal to 0. You get the value of VB plus 99 kilonewton. Sigma V0 upward positive plus VA plus VB minus 50 minus 40 minus the total load. Total load is 8 plus 23 divided by 2 into 6 equal to 0. Substitute for VB whatever you get. VA is 84 kilonewton. Then go back and make a neat entry here and write once again, draw the sketch once again. VB is 99 kilonewton. VA is 84 kilonewton. Remember, one more sketch required. Do not use original sketch. Okay, over. This is option 1. Now I'll do one thing. Go for option 2. Option 2, you make a note. Note. I will make the note here. Where? Here I will make the note. Note. See, uniformly varying load is like this. 8 to 23 here. This is 8, this is 23. Kilonewton per meter you write. Divide into a rectangle and triangle. This will become a rectangle of everywhere 8 and a triangle of this is 23, this is 8. 23 minus 8 is 15. That's how it will come. Okay, write this note and then now you are write one more sketch. Even those who can solve trapezium for understanding purpose, you consider both. See, learning time, consider both. Okay, see, start. Now right here. This will be a rectangle, or you can put UDL also, no problem. UDL, rectangle. Arrow mark. This is somewhere here, right? 8 kilonewton per meter. over that one triangle. This is 15 kilonewton per meter, and stagger the arrow marks. Slightly stagger it so that you can make out the two separated. Okay, now this is over. Two point loads are there. One right wherever is the point load. One point load here, 50 kilonewton. From here is 1.8 meter, wherever it is. One more point load here, 40 kilonewton. From here is 1.5 meter. Now, those who want to make a note, when you consider the rectangle, total load will be center. This is a total load, exactly center. For a triangle, total load for this triangle to centroid here. Remember, from here will be 2/3, from there 1/3. Two loads are there. Start. Take moment about A. Minus VB into 6 plus 50 into 1.8 plus 40 into 4.5 plus UDL 8 kN per meter for 6 meter. 8 into 6 is the total load multiplied by 6 by 2. Why center? This is a total UDL distance plus also this uniformly varying load. Half into 6 into 15 is the total load multiplied by, from here to centroid is 2/3 of 6 equal to 0. You get the value of VB. Therefore, VB will come. Calculate VB. Plus 99 kilonewton. Plus 99 kilo. Oh, see, same answer. Okay, 99 kilonewton. Sigma V0 upward positive plus VA plus VB minus UDL 8 kilonewton per meter for 6 meter is the total UDL. Again minus uniformly varying load half into 6 into 15. This is one more load equal to 0. Substitute whatever VB you got, get VA 84 kilonewton. Then you don't have to write once again. You write answer is tallying. Therefore, question is over. Now, it is left side lesser, right side more. See, you get a UDL and triangle load maximum right hand. Next question, I will give higher intensity here, lesser here. So this triangle will come this way. That is question number 15. 15. Okay. To put the question now, I decided not to prepare the question, solve directly. Okay, 1 minute. This all will be there. Why should I waste it? Okay, this I will remove. That also will be gone. This time I will dictate only. Start. This also gone. Everything gone. Full board gone. Okay. When this much time I can write. Why not I can't write this one also? So I solved. Question. A simply supported beam is of span 5 meter. I have to change the pen. Okay. Is of span 5 meter. It is loaded by an uniformly varying load of intensity 12 kN per meter at the right end, which linearly increases to 21 kN per meter at the left end. Okay, sufficient. Or 21 kN per meter at the left end, which linearly decreases to 12 kN per meter at right end. This is a beam, AB. Along with two couples First couple is 50 kilonewton meter anti-clockwise at the left end. Second couple is anything 120 kilonewton per meter at the right support. Over. Sufficient. No point load required. If point load is there, what you are getting? Okay. Find reaction. As usual, let VA upward and VB upward. Usual statement. Prepare the sketch. Option 1, right here. Option 1 is we are ready for trapezium. Right here. We will note you write yourself only. Just now I told. How many times I have tell the same thing again and again? Okay, this is 21 kN per meter here. This is 12 kN per meter. Reducing. This reaction is VA. This reaction is VB. Span is 5 meter. I can write here. The space problem will come. Span is 5 meter. Anti-clockwise couple of 50 kilonewton per meter here. And clockwise couple of 120 kilonewton per meter here. Okay, now over, that's all. Any other loading is there? No. Right. We will take entire trapezium. Centroid will be here. This is a total load. This distance will be this side plus twice of that side, all told for you. Okay, start. Sigma m about A0, clockwise positive, minus VB into 5, plus, okay, I'll do one thing. I'll finish the couple first. Minus 50, no distance, plus 120, now plus uniformly varying load. Total load, 21, just now explained for you, just 5 minutes back, divided by 2 into 5 is the total load. Now if I explain the waste of time into, from here to centroid is 21 plus twice of 12 divided by 21 plus 12 into 5 divided by 3 equal to 0. You get the value of VB. Okay, I'll put here. Therefore, VB will come. It will come in kilonewton. Right, calculate. You same problem. If I keep the calculator for a long time, calculator gets off. 21 plus 12. 21 plus 12. 5 by 3. Bracket 21 plus 12. 2 into 5. Minus 50 plus 120. 120. 51.5 kilonewton. I check the answer. Plus 51.5 kilonewton. Then sigma V equal to 0, take upward positive, plus VA, plus VB, minus, now couples are not there, only loading. Total load is 21 plus 12 divided by 2 into 5, total load equal to 0. Right here. Substitute for VB. Substitute for whatever you got VB, you get the value of, therefore you get the value of VA. Into 5. This total load is 82.5. 1 nimisha, right. Minus 51.5. 31 kilonewton. Therefore, now go back here and tell this reaction VB equal to 51. Why so? VA is 31, that's all. Yes, okay, because couple is there. 120 minus 50 divided by 5 is 14 kilonewton difference, couple. I got doubt about this answer. Just 1 minute, I will check once again now. 21 plus 12 divided by 2 into 5 is 82.5. 21 plus twice of 12 divided by 21 plus 12 into 5 by 3 into, how much total load? 82.5 minus 50 plus 120 divided by 5. 51.5 correct. Minus 82.5. Okay. 31. Or I'll do one thing right here. This is VB 51.5 kilonewton. VA is, one more sketch you are right, 31 kilonewton. I'll do one thing now. I'll check the answer once again by taking moment about this point. 12 plus twice of 21. 12 plus 21 into 5 by 3 into 82.5 plus 50 minus 120 divided by 5. Some other answer is coming. 12 plus twice of 21 divided by 12 plus 21 into 5 by 3 is the distance into 82.5 is the moment, then plus 50 minus 120 divided by 5. 31. Oh, okay, perfectly correct. I got 31 by taking moment about B. I do not want unnecessary mistakes here. Okay. Option 1 is over. Now write option 2. Option 2. For those who are afraid of trapezium. So, some preliminary required now. See, this diagram I will remove now. I want some space here. I got how much VA? VA you got? VA we got 31. VB you got 51.5. Okay. Now see, option 2. First preparation. 120. I will forget that one. Okay. I'll put this side. Option 2, right there. Option 2. Option 2. See, trapezium is like this. This is 21, this is 12. Divide like this. So, this will become 12, and here 21 minus 12 is 9. So, write 12 here, 12 and 9 here. Therefore, first 12. Little space problem. Okay, I'll put down. This is 12 kN per meter. Then one triangle load. This is 9 kN per meter. This I will remove. Stagger the arrow marks. Now, this is VA, this is VB, total length is 5 meter. Couples are there, anti-clockwise couple of 50 kilonewton meter, clockwise couple of 120 kilonewton meter. Okay, all over. Answer is still there. Okay. Don't see this side. No. Sigma m about A0, take clockwise positive. Minus V, AB another term, actually not required. AB. Minus VB into 5. VB into 5 plus C. One load here. Now I should not explain more. One more load here. This load is UDL. How much? 12 into 5 is the total load. 5 is the total load into exact center 5 by 2 plus once again this UVL total load. Half into 5 into 9 is the total load into from here to here. See, last time it was this way, 2 by 3. Now not 2 by 3. Moment about A is 1 by 3 of 5. Then without forgetting, plus 120 minus 50 equal to 0. Therefore, VB will come 51.5 kilonewton. VB will come plus 51.5. Sigma V0 upward positive plus VA plus VB minus this total load. 12 into 5 is one total load. Again minus this total load. Half into 5 into 9 equal to 0. Substitute for VB whatever you got, get the value of VA. 31 kilonewton plus. Right here, answer perfectly tallying. Okay, now see here, so far, see I have done for beams here this type of load or this type of load or this type of load, and just now this class, one question this way, one question this way. Next class I will do something that is not full span loaded, partial span loaded. Maybe, see, maybe like this way. Then when you take moment, this distance you have to take, but it is important. Okay, that all I will cover in the next class. Then I decided to consider one master question. Beam will start from here, will end somewhere here, where point load, UDL, partial, UVL, all loads including trapezium and couples, everything will be there. It may take little more time, but I will do one thing. I will write expressions and explain. That is next question. Now, two questions for trapezoid UVL represented by trapezium over. Now I have to go to new part. I first, actually not more now, class is only maybe around 20 minutes I think. Maybe usually I feel one more question I will do. No, but it will break the sequence. And also people want short classes. Okay, no problem. Next class I will continue. Okay, thank you.